Welcome back to Teaching Statistical Thinking. In our last video, we covered 4 basic data concepts: data set, unit of observation, variable, and variable type. Today I'll be using those 4 concepts and taking them a step further to describe how we visualize a single variable at a time. The graphics that we'll be using will be the histogram and the box plot. To start, I'm going to start with 4 simple variables that I give you, and then we'll move later to the data set that we used last time, our movies data set. So let's go. Our first variable is going to be, I've got 9 observations, and it's going to be a 3, 2 4s, 3 5s, 2 6s, and 1 7. To draw the distribution of this variable, the distribution means how often does the variable take on each particular value. We're going to use a histogram to visualize the distribution of this variable. A histogram represents the proportion of times the variable takes particular values using area. You'll notice that I've ordered my variable from smallest to largest to make it easy. Because this is a small data set, I'm going to use each bin in my histogram as representing one number. We've got a single 3, so the bin between 3 and 4 is 1 unit high. We've got 2 4s, so the bin over 4 will be 2 units high. We have 3 5s, so it will be 3 units high. For 6, we have 2, so it will be 2 unit high. And it's 1 7, well, it'll be 1 unit high. You notice this histogram has a triangular shape. Stepping back, think of the area in that histogram. 2 of the numbers, 3 and 7, each have 1/9 of the data, or a little over 11%. The 4 and the 6 have 2/9, or about 22%, and the 5 has 3/9, or about 33%. If we add up all of those percentages, they will add up to 100%. Okay. Let's look at another variable. The second variable is going to be the integers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Notice each of those integers occurs exactly once. So the histogram for this data will look flat, with each number getting 1/9, or a little over 11% of the area in the histogram. Again, as we add them all up, the total percents will add up to 100%. For my third variable, it's going to take the value 1 4 times, 5 once, and 9 4 times. When we draw this histogram, the 5 gets one unit, while 1 gets 4 units, and 9 gets 4 units. You'll notice in my histogram that we include the left endpoint rather than the right. The 1 happens 4 out of 9 times for about 44%. The 9 happens 4 out of 9 times for a little over 4%, 44%, and the 5 happens once for the remaining 11%. Again, it adds up to 100%. This histogram is U-shaped. The last histogram that we're going to draw takes the value 4 6 times. Takes a 5 once, a 6 once, and a 10 once. So now you're getting the hang of it. 5 and 6 each get 1 unit. The 10 gets 1 unit. And our 4 gets 1, 2, 3, 4, 5, 6 units. 6 out of 9 is about 2/3, or about 67%. The 5, 6, and 10, 1/9, or about 11%. Again, they add up to 100%. Now notice the first 3 histograms that I've drawn. If I draw a line down the middle of those histograms and fold them over, the left and the right halves are exactly the same. That's called symmetric distributions. In this 4th histogram, there is no midpoint of which I could fold it and the sides would be equal, so it is not symmetric. Instead, it's right skewed. It's got a long right tail, and that'll come into play as I'm drawing my box plot. So this gives you an example of 4 different histograms, all with very different shapes, but they all add up to 100% of the data. Now let's move to the box plots. To draw the box plots, we're going to need what's called a 5-number summary for each of the variables. We'll have variable 1, variable 2, variable 3, and variable 4. The 5-number summary includes the minimum, the 25th, 50th, and 75th percentiles, and the maximum. For our first variable, the minimum is 3, and the maximum is 7. We've got 9 observations, so the 25th percentile will be the midpoint between the 2nd and 3rd observations in our ordered list. For variable 1, those are both 4, so the 25th percentile is 4. The 50th percentile will be our middle value, which will be 5. The 75th percentile will be the midpoint between the 7th and the 8th observation, so for variable 1, it'll be 6. With that 5-number summary, we're now ready to draw our box plot. The box of the box plot represents the quartiles. The 25th, 50th, and 75th makes up our box. Our 25th percentile is 4. Our 50th is 5. And our 75th is 6th. So there's our box. The whiskers of the box plot extend out to the minimum, 3, and to the maximum, 7. So there's our box plot for the first variable. Now let's do the box plot for variable 2. The minimum is 1, the maximum is 9. Here, the 2nd and 3rd observations are not the same, so the 25th percentile will be the midpoint between them, or 2.5. Our midpoint, again, is 5, our 50th percentile. And our 75th percentile is the midpoint between 7 and 8, so 7.5. Now we're ready to draw our box plot. We start with the 25th percentile at 2.5. Our midpoint, our 50th percentile, at 5. And our 75th percentile at 7.5. And that makes our box. Again, our whiskers extend to the minimum and to the maximum. Easy? Now we'll do our third variable. Okay? We notice in our third variable, our minimum again is 1 and our maximum is 9. But now our 25th percentile, the average between the 2nd and 3rd, is 1, the same as our minimum. Our midpoint, again, is 5. And we notice that our 75th percentile the midpoint between the 7th and 8th observation is 9, the same as the max. So for this variable, our 25th at 1, our 75th at 9, our 50th percentile at 5, but we have no whiskers. That leaves our 4th variable. Our 4th variable has a minimum of 4, a midpoint of 4, a 25th percentile of 4, a 75th percentile of 5.5, and a maximum of 10. Okay. Now what we notice in this histogram is that 8 of the 9 points are clustered here at 4, 5, and 6, but one of these points is far from the others. This point is called an outlier. That outlier is going to change how we draw our box plot. Okay? The box is still the 25th through the 75th, so it starts at 4 and goes to 5.5. Okay. However, instead of reaching out to the maximum, this reaches out, the whisker reaches out to what's called a boundary fence. The boundary goes to the 75th percentile plus 1.5 times the width of the box. Okay. For this example, that means it goes to 5.5 plus 1.5 times the width of the box, which is 5.5 minus 4, which is 1.5. This comes out to 7.75. The whisker goes out to the data point that's closest to the fence, but does not extend beyond it. So in our data set, that's 6. And there is no whisker on the lower end. Then we mark the outlier by a single point. I'll just draw a dot. And that's how you make the box plot. Notice how different they are in each of the variables. The box plots for the first 3 show symmetry. Okay. The last one does not, and it has an outlier. Now we're ready to move on to the data set that we looked at in the last video, our movies data set. What I've drawn is the histogram and box plot for the production budget of each of the movies. The production budget is how much it costs to produce this movie, and it's in millions of dollars. Notice that the histogram for the budget is very right skewed, like our last variable. If we look at the histogram, we can see that as much area is in the first bin that goes from 0 to 37.5 as if we stacked up all the other bins. So 50% of our observations fall in the bin 0 to 37.5. If we look at the box plot, we see that the 25th percentile is about 20, the 50th percentile is about 37, and the 75th percentile is about, the 75th percentile is about 71. Our upper fence then will be 71 plus 1.5 times 71 minus 20, which comes out to 147.5. So the whisker extends out to the data point that's closest to that, but not beyond. And then in this data set, we have a bunch of outliers. Now, budget is a numeric variable. Genre is a categorical variable. Rather than a histogram, many people call this visualization a bar chart. But we read it much as we do a histogram. For genre, I've got action movies, animations, comedies, dramas, horrors, romances, and thrillers, and then several others that I haven't written here. What I'm going to do is I'm going to break this histogram up into roughly equal bin sizes. You'll notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the remainders, about 12 boxes of equal area. From that, we can see that our action movies make up 3 out of 12, or about 1/4 of our data set. The animation, romance, and thrillers each take up about 1/12, or a little over 8%. The comedies, 2.5 of 12, or about 20% of our data, and our dramas about 16% of our data. So in this video, I've shown you how to visualize the distribution of categorical and numeric variables using histograms, box plots, and bar charts. Now, before I leave you today, I want you to look at an example that uses these basic concepts to draw a visualization out of the popular press. The visualization that I'm going to use is from the Bill and Melinda Gates 2014 annual letter. The reason I include that graphic is it's a beautiful example how they take very simple concepts, a histogram, and use it to tell a data story. In their visualization, they have 8 histograms that plot the age distribution of South Korea from 1950 to 2010. In each of their plots, they present 2 histograms, the age distribution for men and women, where they've rotated them and flipped them so that they're back to back. You'll notice along the y-axis are 5-year age intervals, ranging from 0 on. And these are the bins of our box plot, but now they're on the y-axis. What you'll notice in the 1950 data is that for both men and women, the age distribution is very skewed, with most of the population at very young ages. The 50th percentile in 1950 was about 20 years of age. As you move across the plot to 2010, you'll see those distributions changing and getting older and older until in 2010, most of the population is in the 20 to 45, which is the workforce age. What this graphic shows us is that as the population has matured, the proportion of men and women in the 20 to 45-year-old group has increased dramatically, giving South Korea a huge economic advantage. Okay. Again, the reason that this graphic is here is because it's such a beautiful display of just simple graphics telling a number story. So with that, I want you to go home and practice these concepts. Open up a data set in Dazzle or in JUMP and try to graph the histogram, the box plot, and we'll pick up there next time to talk about how we actually describe these distributions using number summaries. So see you soon.